Hello everyone, let's conclude few things from what we have learned till now. These instructions what you see on my screen, these are operating on integers. For example, these are the integers. This could be signed or unsigned integers, and these instructions which operate on signed or unsigned integers, they are being called as base integer instructions, and these three instructions form a part of RV64I instruction set. So any CPU core which wants to implement these instructions, they need to at least they will be called as the RV64I CPU core, and they need to implement at least the 47 base integer instructions, out of which I'm showing you 3 at this point of time. Okay, so these kind of instructions are called as the base integer instructions. Next, if you see this instruction, the add instruction, it operates only on registers. So if you see, this is a register, this is a register, and even this is a register. So these kind of instructions which operates only on registers, they are called as R type instructions. So under the base integer instructions or under RV64I, there are again multiple types, and these types there are a range of R type instructions, and the instructions that operate on registers, they are called as the R type instructions. If you see this particular instruction, which is load double word, you have one immediate, you have two registers. So the instructions that operate on registers and an immediate, those are called as I type instructions, because of the name that matches the immediate, it's I type. This is R type. And if you look into the third instructions, which is this one, it operates only on the source registers and the immediate, and also this is being used for storing something, and that's why this kind of instructions are called as S type instructions. So there is a range of instructions which are called as I type, including what you see as the LD. There is again a range of instructions which are called as R type, which are the kind of instructions which are the add kind of instructions, and there are again S type instructions. So these are how the instructions are again further classified. Other than the base integer instructions and floating point instructions, there are further more classifications of the instructions based on the location of the bits that you see over here. So it's being I type, R type, and S type, and there are further more which I'll be talking on as and when we go forward. Next, if you see all the registers present over here, all the registers that has been accessed by either I type, R type, or S type instructions, they are all 5 bits. Now, if you look into some of the conclusions that we have made in the past couple of videos, something like this. For example, if you have a 2-bit, you can represent only 2 to the power 2, which is 4 numbers. If you have 3-bit, you can represent 2 to the power 3, which is 8 numbers. If you have 4-bit, you can represent 2 to the power 4, which is 16 numbers, which is 0 to 15. In the same case, if you have 2 to the power 5, if you have 5 bits, you can represent 2 to the power 5, which is 32 registers. And that's the reason we have 32 integer registers present in the RISC-V architecture. And the naming or the naming conventions of the RISC-V integers are from x0 to x31, which is again 0 to 31, which is what we have seen over here as well. It's basically 0 to 2 to the power the number of bits minus 1, that is 0 to 7. Similarly, it's again 0 to 2 to the power 5 minus 1, which is 0 to 31. And that's why you have from x0 to x31 registers. The ABI, the application binary interface, does a system call through this particular registers. And how does it exactly do it? It does something like this. So the x0 register, the register which is present over here, it's the ABI name. There is a specific name through which you can access the internal registers of the RISC-V CPU core, and the ABI name that is being given to this particular register is 0. The ABI name for x1 is RA. R is return address. We'll talk a lot about the terms which I'm introducing over here in as and when we go further. So the x1 is being called as the RA, where we store the return address. As x2 is called as the stack pointer. The x3 is called as the GP, which is the global pointer. x4 is called as the thread pointer. x5 to x7 are the temporary registers, where you actually store some of the data, or temporarily store some of the data from a few calculations. So I'll talk about that. These are very related to the stack pointer and all those concepts. We'll talk about that once we reach there. X8 is called as the saved register or the frame pointer. As X8 and X10 are called the saved register. From X10 to X11 are called as the argument register. So these are the registers where you can pass on the arguments. I'll again talk about that once we reach there. X12 to X17 are something again the argument registers. The x18 to x27 are saved registers, and x28 to x31 are again temporary registers. So we'll talk a lot about each and every one of them. What does each and every one of them mean to us? For now, for example, the way ABI, the application binary interface, accesses the internals of the RISC-V architecture are through these names. If you see some of the sample codes that we have introduced in the beginning, these are the names A0 SP, A0 RA, and so on. So these are the application binary interface names, or the ABI names, through which the programmer accesses the RISC-V CPU core through some system call function. So this is what the ABI is all about. Next, what we'll do is we'll actually look into the entire thing. We need to look into what does this exactly means to us. So for example, what does the return address, what does the hardwired 0, and what are the terms called as caller, callee, and so on. So what we'll do is we'll stop at this point, and we'll start from the topic of memory allocation and stack pointer, where we'll be introducing to some of these terms that you see on my screen. So let's stop at this point, and let's start from the memory allocation and the stack pointer from the next video. Thank you.